And thanks a lot to everyone for joining. Yeah, Patricia was right. I'm also a Traefik ambassador, and I totally forgot to put that here. So sorry, Patricia, that's my mistake. So yeah, today I'm going to talk to you about Kubernetes, about Traefik, of course, and our internal monitoring as a service offering. And of course, I'll start out with talking a bit about Haufe Group and who we are. So, but let's start off with who am I? So like Patricia said, I'm Nicholas. I'm doing this kind of thing, like talking at online meetups, at conferences, or doing webinars in my own time. And to be able to do that, unfortunately, I need to work. But fortunately, I'm able to do that at Haufe Group because, well, it's an awesome employer located in Freiburg, Germany, and been there for quite some years as a DevOps engineer and looking after our containerized environment to provide services for our developers. But let's start a bit earlier. Let's first start with the question, what is Haufe Group actually? And after we took a look at that, I'll talk about our architecture. So we will talk a lot about Kubernetes, but we will talk even more about Traefik because that's one of the cornerstones of our architecture. And we'll shed some light how we solve the question of high availability, how we solve the question how we provide certificates or TLS connections for our users, and how we do automation around that. Because I'm not a guy who wants to stay up late at night to get things working or fix stuff or update things. And in the end, I'll also talk about our internal offering called Monitoring as a Service. But I'll not spoiler anything what this is about, but you can probably tell from the name, but we'll get to that. So what is Haufe Group? We are a family-owned enterprise. We are founded, well, it's now 70 years ago, and we're among the leading software media companies in Germany. So we've got 90 locations all around Europe, but the headquarters is in Freiburg, and yeah, we have a whole campus there with several buildings and hundreds and hundreds of developers. Overall, there are around 2,100, 2,200 employees. Yeah, it's hard to tell how many developers we actually have. Sounds weird, but that's because our development teams are working in an autonomous way. They are not, we don't restrict them in too many ways. And there are dozens of them. So always new development teams for new ideas, new products, new projects. Then other things, well, they just don't cut it. They end, and so teams also disappear. So there's always a change, and it's really hard to tell. But I think if I say dozens of development teams, that's probably right. And they are different sizes, starting with 1 or 2 developers and up to 20, 30, 40, 50 developers, depending on the size of the project. So what are we actually doing? Because software media company sounds a bit vague. From the early days of Haufe Group, the first products we had were converted into digital media. So we did, in the beginning, we did a knowledge base for lawyers, accountants. In the beginning, this was just paperwork. And it was a big book of hundreds and hundreds of pages. And well, the update in those days were like shipping new pages with instructions like, please substitute page 127 with this one, and page 572 with the other one. And luckily, someone realized that it's a lot easier to do this online and in a digital way. So that's how it works today. But I'm told we still have a few customers that still rely on the paper versions of those knowledge bases. It's really weird to think that people have hundreds and hundreds of pages well, on their walls, but that's the way it is. The software we are creating is also around managing your business. So it's for doing taxes for the end user, but also for tax offices. It's for accountants, for human resources, for talent management, ERP, real estate. So it's a really wide range. And Another thing we're doing is seminars and brokering those. So on one hand, we are offering seminars ourselves, and on the other hand, we're making sure that companies find the correct trainings or the best trainings for their employees on the market, not necessarily from us, but from someone else on the market. Yeah, and then some numbers that are supposed to sound great. So of course our revenue is huge and it's always rising. I think the most important thing is that we handled the Corona crisis very well. Of course, we felt that something was different than before, but we managed to get through it without losing too much. But of course, it hurts such a crisis. Okay. Now that we're going from what is Haufe Group over to the technical part, let me also mention that I'm happy to answer questions in between. I'm trying to follow questions on my screen down here. So when I'm looking down, I'm not falling asleep. I'm actually looking at the questions, but I've also got, organized with Patricia that she'll help me with the questions. And so don't feel left out if I'm not reacting immediately. Okay, so what am I actually doing? As I said, I'm a DevOps engineer and I'm working in a team of 8 engineers, and we are running quite a range of different services. So I've put them on here. So it's Jira, GitLab, Artifactory, JFrog X-Ray, Team Foundation Server from Microsoft, GoCD, the build agents for those systems. We are running SonarQube and this monitoring as a service. And so it's a really wide range, and that comes from the fact that we as Haufe don't believe that all development teams should be forced to use the same set of tools. So many teams are happy to use Jira, but some are also interested in Team Foundation Server. Some teams want to put their code in GitLab. Others want Team Foundation Server. Some teams want to build their code with GitLab, others with Team Foundation Server or GoCD. So we are offering different services for the same thing. So there's more work for us, but in the end, we believe that teams are more productive if they work with the tools that they really want to work with. And so we're trying to put very few restrictions on teams. The only things that I need to follow are things that come from compliance or from laws, from data protection, that kind of stuff. So our main challenges are that we need to manage the lifecycle of those services, of those very different services. At the same time, we are there to help teams use those services. Not only like how do I log on to GitLab, but also what are commonly used practices to write a pipeline in GitLab, or how do I upload an artifact into Artifactory? So we often have design sessions with teams to help them create pipelines and connect those services together. But in the end, while doing all that, we need to balance the time we spend for work and for family. So we'll get to that later as well, but we are investing a lot of work into automation because like myself, my colleagues don't want to stay up at night to automate a service that needs to be up during working hours. So that's one of the most important things for us, to run things as easily as possible. But at the same time, with as many features as possible to help our teams develop their products. So we are if you're speaking about organization, we belong to the internal IT, but we're a separate team and just focusing on the development teams and the services they need for the DevOps process. Okay, and just a few numbers. So our Artifactory now uses 16 terabytes of storage. We got down from around 35 lately because we did a cleanup of old artifacts. but now we only have 1.4 million artifacts. Funny story is, when I started at Haufe, we were at around 140,000. So since I started at Haufe, artifacts have multiplied by 10. GitLab provides thousands of repositories to around 1,100 active users. We have around 2,500 build jobs on Linux per day across all pipelines. So when I say build jobs, if you know GitLab, for example, it means that a pipeline is separated into jobs. Every job is counted. So that's how the 2,500, that's where they come from. We also have Windows desktop products. For that, we have around 100 Windows VMs to build and test those desktop products. Then we have this monitoring as a service in 15 instances. And one thing I was really interested, I thought, well, let's take a look how many connections per second Traefik is actually serving. And when I looked at 60 to 100, I thought it was weird. I thought it felt rather low. But when I took a closer look, I realized that, well, a connection means that several HTTP requests can be served in one connection. So 60 to 100 can mean that it's, well, actually a lot more of requests served by Traefik. So that's just a few cornerstones, a few facts. So you have an idea about the size of our environment. When you look at GitLab and see 1,100 active users and think about our roughly 2,200 employees at Haufe Group, that doesn't mean that only half of them are developers. It just means the employees have something to do with GitLab. So those are developers. Those are also marketing people who store stuff in stories. It's also people translating software who are working with code repositories. So it's a wide range of people using a service like GitLab. It's also one of our most prominent services. So Artifactory and GitLab are the things that many, so also dozens of teams are using. Okay, let's take a closer look at the platform. So I tried to put it in an easy diagram. Hope I succeeded. So Traefik is the cornerstone to get to our services. What I haven't mentioned so far is that except for Team Foundation Server, which is a Windows service, everything else is running as a container on Kubernetes. And to reach those services, to reach those containers in Kubernetes, we're using Traefik exclusively. So there's no other way to access these services except for admin ways, but a user must use Traefik to get there. Traefik has helped us for years, for many years, and it's rock solid. I get to a thing later, but we're also doing regular cluster rollouts of Kubernetes, and between those rollouts, we've never seen a single restart of Traefik that was caused by Traefik itself. So it was working rock solid all the time. So when I'm talking about those Kubernetes clusters, it's all self-hosted because at the time when we started with containerization, we didn't have a proper cloud strategy yet. So we decided to do it all ourselves. Also because when you run those different services, you need to think about the connection between the services. So which service is talking to which other services, and does placing one of them in the cloud really improve my performance? So if the network bandwidth is really important, then extracting one of the services from an on-premises cluster, placing it on the cloud, may not be what you want to achieve, because things get slower because you don't have the bandwidth as in your data center. So in the end, we have one important cluster which has the opportunity to reach a few services from the outside. So we have very few services that are exposed to the internet, and they are reached via a special instance of Traefik, which is running in our DMZ. And then we have a separate instance of Traefik, which is running in the internal network. So if an internal user wants to reach a service, then he reaches the internal Traefik. If it's an internal service, a service running internally from internal. So in the end, to reach all those services and with different endpoints, we currently have around 270 Ingress rules and 200 middlewares defined. But 200 middlewares only because for every HTTPS rule, we have a redirection rule with a middleware. So yeah, 200. If you subtract those redirection middlewares, then it's probably, well, let's say probably around 100, 110 different middlewares for authentication, setting header fields in HTTP requests, that kind of thing. And to decide on which Traefik a service is bound, so if a service is reached from the external Traefik or reached from the internal Traefik, that is done by a label selector on the Ingress rules, which is probably something that you've seen if you're using the Kubernetes provider for the Traefik configuration. You can specify a label selector. That means the Traefik will only process objects or resources in the cluster that have the special label defined on it. So an important question that always comes up is why do we have an internal and external Traefik? The main reason for that is our DMZ has a different network architecture and well, a different throughput, and meaning a lower throughput. So our internal network is running at 10 gigabytes per second and the DMZ at 1 gigabyte per second. So if we were using hairpin mode to redirect everything through the Traefik instance running in DMZ, we would slow down everything that's coming from the internal users. And if you're thinking about uploading large stuff, large artifacts to Artifactory, for example, that's something you don't want to see. Because if your artifact uploads takes 10 times what it took before such a change, then well, users will not be happy. And if we have to invest a bit more work to keep our users, well, it's not the only thing that keeps them happy, but if it contributes to them being happy, then well, then we just invest that work. So like I said, Traefik is the cornerstone for accessing the services running in our Kubernetes cluster. Okay, so how do we do high availability? The great thing is we don't have something like an SLA. So although we are some kind of service provider inside the company, so far nobody has forced us to commit to something like stuff will be up with so and so many nines, so 99.999%. So currently, these services that I mentioned earlier, none of them are running in some kind of high availability mode. Also, Traefik we are not using the high availability option in the community edition of Traefik. So the external and the internal Traefik are both actually single instances that can fail over different nodes. So for example, the DMZ has 2 nodes and Traefik can fail over between those 2 nodes in case one of those nodes dies. But as you probably know, nowadays that a VM dies for some reason, that has become really, really rare. So yeah, so we will not kill one of the nodes because it never happened, but we are really lucky that, knocking on wood, that we haven't seen any major outage caused by a VM. And well, then the internal clients, that those clients can connect to the internal workers directly. So the internal Traefik instance can fail over all workers that we have in the data center. Yeah. Okay. And another important cornerstone of our architecture is that we do we organize access to our services through DNS. So the only A records we have in DNS is actually the IP of the Traefik endpoints, and every service is just a CNAME to that load balancer. In that way, we don't have to reconfigure any service if traffic fails over to another node or needs to be restarted on another node, because DNS will automatically update the IP address of if a request comes in for a CNAME that points to an A record that has a new DNS entry. The important thing is to mention that if you're doing that, you need to put a really small TTL, so a small time to live on the A records, because otherwise a change will take quite a long time to propagate through DNS. So if it's like 10 minutes or even an hour, it will take really long for anything to fail over. Also important, if you're relying on DNS, is that you should avoid running DNS servers yourself that override a default TTL. So sometimes, let's say, an internal IT department decides that they know better and that a small TTL just places too much load on a DNS server and they override small TTLs. That's something we need to avoid. And also, just a heads up, domains have a time to live for negative caching. So if a record does not exist, DNS servers can now cache this information, and the TTL for that is usually at least 1 hour. So if you delete a record and then recreate it, and in the meantime someone asks for it, then it's probably over for an hour. So remember that. Okay, let's jump over to the demo environment. So what I've done is I created a Kubernetes cluster with Kind, so Kubernetes in Docker, the thing that the Kubernetes project itself is using for development and testing. And while I was doing that, I realized, oh gosh, that is so similar to our environment. Yeah, it was a pleasure to see that I didn't have to do complicated things to emulate the internal, the external network. So what I did was, the first worker in the cluster serves as the external endpoint, and it will be reachable on ports 80 and 443 from the outside, meaning that if you know Kind, then you can tell that a special node like this first worker receives requests to port 80 and 443 from the outside, and all other workers are only accessible from the inside, also the controllers. So like the API server is only reachable from the internal network. But to emulate the way to the internal network, I implemented a proxy that is also running. So if I run requests through the proxy, I will be on the internal network. And so I can show you both ways how to reach the environment. So that means compared to the earlier picture I've shown, there's no real network separation between the internal and the external traffic, so it's just logical. So the Kind network, the network that Kind has built, represents the internal network, and the first worker represents the DMZ. Okay, so let's quickly jump over to the console. I hope the size is fine. If not, let me know. I can change that. Okay, let's first look at the nodes. So I have a Kind cluster with those 4 nodes, one control plane and 3 workers, and the split proxy running next to it. If you figure out the IP address, don't try to break into Squid. Is also authenticated. I'm not saying that it's impossible, but let's be nice, okay? Okay, what shall we look at first? We have a few namespaces. The important thing is probably in the default namespace. So that's where we have our 3 Traefik instances. So far, I haven't really talked about the QA instance. We have decided to run a third instance, which is meant for debugging. So if we have the feeling that something's wrong in the network, in the requests on the network, we can place a service on the QA traffic, which has the debug log enabled. Now we can look at the logs in traffic and probably figure out what's going wrong on the network. So that's why there is a QA traffic. Okay. Then those, let me quickly show you where those things are running. So like I said earlier, the external traffic is running on the node that is also meant to be available from the outside. Or let me prove that. So if you do an inspect of then we'll see the port forwarding. Oh, it should have been down here, right? Oh, I looked at the control plane. Oh, that's stupid, of course. You know, I want to look at the worker, and the worker has, yeah, the first worker has those two forwardings. So when Kind created the cluster, it created those two forwarding rules that any connection to the host is redirected to the traffic instances. So, and then we can start looking at stuff. Is this where I have a page with links? Yeah. So let's take a look at stuff. So this is the traffic instance. I'll quickly show you the, come on, let's leave full screen mode. So we have an endpoint like traffic-external, and that is a CNAME for the internal load balancer. And I can also show you that. So I don't have to type anything. Let's copy this and remember to add an O at the end. Oh, let's not do this short. So like that. So when someone's asking for the dashboard of the external traffic, it's just a CNAME that points to the internal load balancer. And of course, I'm publishing the traffic dashboard on the internal load balancer because people from the internet are not meant to look at my dashboard. That's something that we as administrators want. So if something goes wrong, we need internal network access to reach the dashboard. And then we have a list of rules. And like I said earlier, all our rules, all our HTTPS rules have a matching HTTP rule to do redirection over to HTTPS. And like I said earlier, I know there's a way to do this globally on the HTTP entry point, but we still have some old HTTP endpoints that we need to keep. So we cannot get rid of HTTP endpoints yet. So, but mind, they are only on the internal network, so no HTTP access from the internet. So if we then look at the internal network, this looks a bit more interesting because we have more rules. We see the dashboards for traffic, and we see other rules that we'll talk about a bit later. And yeah, and you also see that's how you get to the large number of Ingress Roots, because we always have two. And if you also take a quick look at the QA thing, then that's, oh, that is a mistake. It doesn't really make sense to publish the QA dashboard on the QA traffic. That's something that, yeah, probably messed us up when I built the cluster. Yeah, just ignore this. It's also QA, you know, I can restart this anytime I want. No one is actually relying on this. Okay. Ooh, oh yeah, this is where my demo, my slides are. So let's go quickly back to the demo environment. Oh yeah, I also want to look at the Ingress Roots with you. Let's go back to the console. Let's say we, also, so I haven't really explicitly mentioned this before. We have decided not to use the Ingress objects provided by Kubernetes, but to use the Ingress Roots because of the feature set, because the CRDs or the custom resources that Traefik ships with are much more powerful than what the Ingress object with labels allows. So that's what we're using all the time. So we're looking at the Traefik external and look at the YAML, then, well, you see that kind of rules. And well, it's not very surprising, right? So we have a host rule that matches the endpoint that we want to reach. In this case, we have an auth middleware because I don't want anyone on the internal network to reach traffic without authentication. And then, of course, the service that all of this redirects to or routes to. Okay, let's look at the next aspect. So certificates. In the beginning, we used Traefik and the ACME, the integrated ACME as our provider facility. But when we started putting services on the external, then on the internal and the QA instance, we realized that anytime we change the assignment of a service to a load balancer, that load balancer had to ask for a new certificate. So in the end, we started pulling more and more certificates over the 3 instances of Traefik, and we started using up our free number of certificates, which is 50 per week right now. And we are currently using 130 certificates. So if you're playing around, you're removing something and adding something, and maybe resetting traffic and losing all of your certificates, then suddenly you're using up all your rate limit. So we decided to use Cert Manager for certificates, and we have a single Cert Manager instance running per cluster that is responsible for getting certificates. And the way Cert Manager works is it places a certificate in a dedicated secret. So this secret can be used by any traffic we want. So if we put a service on the internal traffic, then it will just use the secret that is mentioned in the Ingress root. And some of you probably noticed this down here. It says that this Ingress root on the HTTPS entry point uses a certificate, and the certificate is stored in a secret which is referenced here. And this secret is then managed by Cert Manager. So meaning that if we look at, let's first look at the secrets. And we see there are 3 certificates for the 3 different instances of Traefik. And if we look at the certificate resource, which is the CRD that the Cert Manager ships with, it gives you this connection. So the definition that this, the certificate for the external traffic, at the moment it's ready. So meaning that a valid certificate has been issued and is available, and it's available in this specific secret. So if we look at the definition, it is a bit longer, but I think this part is the most interesting. So it tells that we need a certificate with this specific common name. And the way that Cert Manager works is that you tell Cert Manager which issuer to use. And we have a so-called cluster issuer. So a definition who can publish or who can issue a certificate for anyone in the cluster. And that's what the Let's Encrypt cluster issuer does. So whenever a certificate custom resource references this custom issuer, Cert Manager will make sure that a matching certificate is pulled from Let's Encrypt, placed in the secret, and then Traefik is able to use that certificate for HTTPS. Okay. Then automation. I briefly mentioned that automation is a really, really important aspect for us. Even this demo cluster that I created, that's something I created from our pipelines that we use to configure a cluster. So normally our cluster deployment is based on KubeSpray. That's also one of the official projects from the Kubernetes project. And it's actually a huge collection of Ansible roles that creates a Kubernetes cluster and is highly configurable. In my case, I created the kind cluster by hand and then ran the pipelines that we have for configuring the cluster directly against my kind cluster. Well, not really directly, but a bit of magic involved, but yeah. And then what we're relying on whenever we can is declarative infrastructure. So we don't want to write a complex script if we can avoid it. And that's why we're using custom resources wherever we can. So we're managing ingresses with, like I mentioned before, with the Ingress Roots CRD that ships with Traefik. We're using the certificate CRD shipped with Cert Manager, and also all the DNS entries that are necessary. So the C names that I mentioned earlier, the A records for Traefik, all of that is managed by external DNS, which ships with a CRD that lets you define DNS records. So let me quickly show you that. So there's a Cert Manager namespace and there's an external DNS namespace, and those are the two services that I just mentioned. We also already looked at the certificate CRD, but there's also the DNS endpoint. And you probably guessed it, the Traefik dashboard also has a DNS endpoint custom resource. So if we look at Traefik external again and take a look at the YAML, then the specification is actually quite small. It just says that the DNS endpoint for Traefik external is a CNAME, and it points to the internal load balancer that is provided by a specific cluster. And that way, we're also able to define DNS endpoints in a declarative way. In the beginning, we actually had separate pipeline jobs that were responsible for updating DNS, and you had to do API calls to the DNS provider and make sure that the endpoint was updated. But yeah, in the end, external DNS is a great help for automation, because it also makes sure that once external DNS has created this record, it also creates a matching TXT record, which defines that that external DNS is responsible for that DNS record. And if you manipulate the ownership information in the correct way, then you can make sure that a very, very specific instance of external DNS is responsible for a certain DNS entry. And we're getting to that in a second. It's probably on the next slide. Yeah, when we're doing cluster migrations. So every now and then we decide that we need to migrate from one cluster to the next. And that is, let's say it's semi-automated. So the rollout of all our services is automated, but not which cluster it's rolled out to. But as soon as we tell a deployment pipeline to roll out to a new cluster, it checks where the current DNS records point to, and they still point to the old cluster. And then a whole new logic starts to run. So it will then make sure that the old instance is correctly shut down. and it will export the certificates from the old cluster, because if we have to reissue all certificates in the new cluster, then we'll hit the 50 certificates per week really quickly. Like I mentioned earlier, 130 records. There's no way we can pull this off in 1 week. So it's more like 3 weeks. And well, I don't want to spend 3 weeks on a cluster migration. So we just migrate the certificate secrets from the old cluster to the new one. And that's also where the external DNS ownership thing kicks in, because it's not possible to that the deployment in a new cluster takes over the old record because of the ownership information. And we're actually changing that in DNS. So the problem is, if we delete the DNS endpoint custom resource, then the DNS record gets removed, and then we may hit the negative caching. If someone asks for a DNS record while it's gone, then it will be cached that the record does not exist. And that's why we change the ownership information of the record and do not delete it. So when the new service comes up in the new cluster, the new external DNS instance will realize that it is the owner of this old record, but that record has an old value. Of the DNS record. So now let's move over to the monitoring thing, because that's also what I wanted to show you. For monitoring, we have a per cluster Prometheus server running, which is managed by the Prometheus Operator. So that is collecting lots of stuff from the cluster. Do we have the links here? Yeah, so we have let's quickly take a look at the cluster Prometheus. So if we look at the targets, we have quite a long list, and the most important things are that everything in Kube system is scraped. So the Kube API server, the controller manager, Kube proxy, Kube scheduler, kubelet. We want metrics from all of those systems, from all of these services, but we also want to pull the metrics from Traefik, so we can look at live usage of all Traefik instances. We also want the metrics from external DNS and Cert Manager, and from other things in the cluster, so like our monitoring stack. We also want to monitor the Prometheus Operator. We have the node exporter, which is monitoring the nodes, the Kube state metrics, which are creating, let's say value add metrics for the cluster. And that is all done with the Prometheus Operator and the Service Monitor and Pod Monitor CRD. So, that's where the slides are. Now, and while we were doing all of this monitoring stuff, we realized that we're probably not the only one who want to be running a monitoring stack. And we thought that maybe that's something we can offer as a service internally, so that we as an infrastructure team run the monitoring stack, and teams are just using it as well, like a customer. And that's when the monitoring as a service offering was born. And by now it features quite a lot of components. So actually it's more like a Grafana as a service, because that is the front end to any kind of data that is collected. But we also have an InfluxDB that gets data from a telegraph, and we have a chronograph service running to manage the InfluxDB. We also have a Prometheus running with a push gateway, and Loki with Promptail. So we have Grafana for visualization, we have InfluxDB and Prometheus for data collection, and we have Loki for log shipping. And all of that is integrated into Grafana. So why do we have two different stacks? So we came from InfluxDB, from the TIG stack, and decided to migrate over to Prometheus, because it's much easier to monitor the Kubernetes cluster. But we decided not to remove the InfluxDB from monitoring as a service, because other teams are really happy using it. So we're running all of these things, and every instance of monitoring as a service has an isolated set of all of these services. So we're not doing any kind of multi-tenancy inside of Grafana or Prometheus. So every instance is isolated and dedicated. Okay. Yeah, great. We are nearly there. So if we're jumping over to I have a really, really small instance of Grafana running here with only a few dashboards. For example, the Traefik dashboard. Let's rather look at the last 3 hours. So there's not much happening, but you see what I've done here. So for example, this here is the internal load balancer, and we see that I've been using the Traefik service, which is right because I've just looked at the dashboard so far. Then down here we see the different entry points, how they are used. But now look, we now see a spike that our MAS instance has been used over the external load balancer, and that is Grafana. So I've published this Grafana on the external load balancer. Let's take a quick look at that. So this is the Traefik external dashboard. Let's make this a bit larger. And on this one here, we have this name. This is the MAS instance, so test_n. That's my instance of a MAS instance. And if we then move back to Grafana, you see that name here in the URL. So as soon as I started to hit Grafana, Traefik updated the metrics that were collected by the cluster Prometheus and pushed to the MAS Prometheus, and that's where this graph comes from. And as one of the last things I'd like to show you is we also have monitoring for things like the different namespaces. Let's say you want to take a look at the workers and let's say the MAS instance. And yeah, so we have different dashboards that all work in the same way. Data is collected from the cluster with the cluster Prometheus, then pushed into our personal MAS instance, and so our personal monitoring as a service instance, and then displayed by our personal Grafana in our monitoring as a service instance. Okay, and then we're actually at the end. So let's wrap this up. The QR code on the side is a link to the slides. The link at the bottom brings you to the GitHub repository where my slides live. Like I said, Haufe is a family-owned software media company, and I'm a really happy employee. We as a team do service offerings that support dozens of development teams in their DevOps process or the DevOps cycle. And Traefik is one of the most important cornerstones, a crucial component of our architecture. And like I said earlier, it's running rock solid, and not only from a stability point of view, but also from a performance point of view. And we are heavily relying on declarative infrastructure because it makes our automation much more simple. And what I've shown you at the end is that we have this monitoring as a service offering, which is a great success in the company. So we currently have 15 instances, and yeah, I don't see an end to it. So teams are onboarding almost every second week. Okay, so now I'm done with my part. I'd be happy to answer your questions now.
So I'm going to pop in. It's Patricia.
Awesome.
First of all, on behalf of all of us, a big clap. So let's dive right into the questions because we have a lot, and Tony, Matthew will add yours to it as well. So if it works for you, Nicholas, I'll just read to you one by one the ones we've compiled.
Awesome.
Now, warning everyone, we had several that seem like very great questions to me, and so we'll try to answer them in the next 6 minutes, but we may carry on a little bit longer. So for starters, why did you choose Traefik? Have you considered other Ingress or API gateways? If we need Ingress in Kubernetes, could you suggest to us why Traefik is your preferred choice?
Okay, so at the time when we jumped on Traefik, there wasn't so much choice on the market. So of course there was the Nginx Ingress, but one thing that was really important to us was a TCP forwarding, because like I said, we're running GitLab that involves an SSH connection, which requires TCP to be forwarded, and many API gateways or Ingress offerings don't offer TCP. So that narrows down the market. And in the end, when we tried Traefik, we didn't really look left and right anymore. So, well, actually, we're just happy with it.
What a great way to put it. Thank you so much for that. And of course, we appreciate it. The next question is, where does Traefik fit in? What does Traefik do when it comes to load balancing, Ingress, observability, service mesh, service proxy, API gateway, and tracing? Or does it do all of these?
Wow. So that's a question. So I can't really speak for tracing. You've probably gathered from my talk that we are an infrastructure team. We are infrastructure guys. We're although we do have one or two developers on the team, we're not a development team. So we're actually looking at running infrastructure. And one thing that we realized quickly is when it comes to keyword service mesh, that it's something that you as a developer really is something that you might think about using, but as an infrastructure team, it's not as crucial. So that's why I'm not talking about service meshes. That's why I'm not talking about tracing. But I've showed you how we collect metrics, how we aggregate them from Traefik and with Traefik. Hope that answers the question.
Yeah, and we have a blog somewhere here that I will find about tracing. And of course, we have some documentation about Jaeger. So the next question is, how mature is Traefik in supporting alternative services as part of the overall solution? We might want to use AWS API Gateway, but we need to swap out other components. So how mature is Traefik in supporting these alternative services?
I must admit, although we have many development teams running on AWS and Azure, so they mostly decided on one of those cloud infrastructures. I don't really have much experience with the API gateway. So my first feeling when it comes to a cloud provider is that you probably want to look at their own load balancers first before running it on your own, because if you're using the service provided by the cloud provider, usually it's tightly integrated with the other services. So for example, the API gateway will probably integrate with the Elastic load balancer in AWS. But yeah, maybe there's good reasons to run Traefik on top of that as well, but I'm not aware of them.
Okay, thank you. Next is, with all of the flexibility and different tooling, it must be important to expose health of the platforms, not just enable functionality and services. How do you represent health in a common way, so many different components being used by different teams? Let's just say for many different components.
Yeah. So, well, it's often a question of how to interface with the teams, and the more teams we have, the more developers we have, the more employees we have, the more difficult it gets to get the information out to them. So it starts with something very formal, like a ticketing system where people can raise a ticket if something breaks or they need something out of the ordinary. And that's usually the thing that alerts us very quickly. But we have also, let's say, personal interface into the team. So we know people on different teams, and we keep in touch with them on a personal level to get feedback, to understand what their problems are. and we really try to document typical things in a kind of service documentation. But as you all know, it's really hard to look with the right point of view. So from a user, from a customer inside the company. So that's probably something we can also improve on.
Okay, cool. Thank you so much. Next question is, how do you discover the Kubernetes ingress from the external traffic with your labels, or do you push the external rules from Kubernetes to external traffic?
No, so it's all in the same cluster. So so if we're looking at the services cluster where all our services run, it's one cluster with hosts located in the DMZ and hosts located on the internal network. And so the traffic uses the same API server as the internal hosts or the internal traffic instances and sees the same things. And traffic can then look at the labels and decide which of the custom resources belongs to the external traffic or doesn't belong to him. So it's all the same cluster, so there's no need to push anything to traffic. Traffic just discovers the stuff on the cluster.
Excellent. And what kind of providers are you using for traffic? How do you handle authentication with traffic? And are you using external auth middleware? And just, I'll add a little something here that I'll throw in the chat boxes. We just had a great webinar about authentication, so you might want to check that out.
Yeah, so sorry, what was the first part before authentication?
Oh, yeah.
Sorry.
And just a note to everyone that we're just at time right now, so we'll be wrapping up shortly, but thank you to everyone who has to run to a meeting for joining us, and we'll send the recording out shortly. The question was, what kind of providers are you using for traffic?
Okay, so mainly we're using the Kubernetes provider. We are thinking about using the file provider to configure TLS a bit more, so like limiting which TLS version to use and that kind of thing. But mainly it's just the Kubernetes provider. So great. Now I forgot the second part of the question.
Oh,
sorry,
how do you handle authentication with traffic?
Okay, so traffic is only responsible for authentication when it comes to our administration. So reaching the traffic dashboard, for example. When it comes to the service that we run, like GitLab, Artifactory, and so on, that's something that is configured per service inside the service. So, for example, GitLab may be running against LDAP or using XAML or OAuth authentication. It's not like we're using traffic for authentication to these services. That is handled in the services individually.
Okay, excellent. And are you using the external auth middleware?
No, not yet. I think we talked about it a few days or weeks ago, but it would be interesting to go to leave the basic auth middleware and use something more centralized like the external auth. Is that covered by the webinar that you posted in the chat?
Ooh, I don't recall.
Oh, I'll look at it anyway.
Hot seat.
Yeah, because creating my own middleware would be really interesting stuff. So yeah, I'll look at that.
Excellent. Okay, thank you. Next, is it possible to do service-to-service authentication authorization using middleware of traffic without exposing these services to the outside world?
I think service-to-service authentication is something that is more of a mesh feature. So that would be a service mesh feature. So it could be a mesh or any other thing, but I think service-to-service authentication, you can probably hack that in traffic, but I don't feel it's something that belongs into traffic alone as a component.
All righty. Thank you. And is there a reason you chose to use Prometheus Operator rather than Prometheus Helm charts?
Well, we could talk another hour about Helm charts and our decisions concerning Helm charts, but I leave that out. So what we like about the operator is that we don't just run the cluster Prometheus instance provided by the operator, but also every Prometheus for every Mars instance is actually created by the Prometheus operator in the cluster. So it's not like we run the operator for one single instance, it's actually creating several instances inside the cluster. So that's why it's easier, because it just is a custom resource that we create, and bam, there's a new Prometheus.
Awesome. Do you have to provide SLA reporting for management? And if you do, how do you handle reporting and scheduled downtimes?
The awesome thing is we don't have SLAs, and we don't have to report about downtimes. So we can schedule downtimes when we see fit. We just need to have, let's say, an appropriate notification in advance, so that teams can either coordinate to make sure they are not working in that window, or they can intervene and veto a change. But usually changes are done automatically at night. So like an update, that's something that we schedule for a specific time in the week, where we have a kind of, let's say, regular maintenance window, and that's when an automated update happens without us interfering with that, or us doing it manually.
Okay, awesome. And why have you chosen Loki and Promtail instead of Elk or EFK, which seem to be the standard for log aggregation right now?
Yeah, because we want it to be different. No. We didn't feel like we needed a full text index for all the logs, and we wanted to start small. So we decided to use Loki, which is actually just pushing lines into storage, and then you can grab on them. And we have put that on we have talked about whether it's the best thing for us, or we need to move to the Elk stack, but we realized that grabbing in a GUI for problems works great for us. So it's actually a question of preference, not that we think that Loki is superior to anything else. It just fits to our way of work.
Very cool. And then someone asked if you could please share your external Traefik dashboard URL. So I think this is a good time if you'd like to share your slides here, and then I'll include them with the recording and the email if you'd like.
Is the question meant that I'll provide access to my dashboard URL? Because that's...
Oh, the question, sorry, I kind of party hopped there. So the question is, would you share the external dashboard URL?
Okay, that sounds a lot like someone wants to access my external dashboard. That's something, of course, I won't do, because that's a demo environment. I'll tear it down later. And yeah.
Okay, well, that just reminded me to maybe bring up your slides to share them now. If we have the link possible, we could share that in the chat box.
Oh yeah, that's a good idea.
For the slides, yeah, and then everyone, we're about to wrap up, but I'll include the slides in the email that we'll send to you shortly with the recording of this, in case you'd like to watch it again.
Yeah, so that's yeah, right. So that's what I posted is a link to the release where there's all the information that you need.
Well, look at you, Nicholas. I'm sorry, Ruan Becker is helping us out. Thank you so much. And then the last question is open my document. The last question is, does Traefik support your own customized plugin and middleware? And you may have something to say about this, but I will also say that I had thrown in the chat box a blog all about creating your own middleware.
Yeah, so we're not using custom plugins right now, but that's something that we're planning to look at.
And then someone just asked, oops, I'm sorry, I just sent that blog just to one person. Someone just asked about our YouTube channel. So Jay, you may subscribe to our YouTube channel that I have just thrown in the chat box. Thank you for your interest. And then let me share this blog one more time to everyone about middlewares. And I would say from my side, that's all of the questions, but brilliant work by Nicholas, brilliant work by the attendees. It's so wonderful to have a vibrant communications with you with your questions. So we're going to follow up shortly with the video, and I'll include the slides in the email. And thank you very, very much. And Nicholas, I'm sure you may have some parting words for the crew.
So thanks a lot for having me. It was great. And thanks a lot for all the questions. Yeah, and have a great, well, evening in Germany and rest of the day in the US or wherever you are.
Thanks, everyone. Have a wonderful day, night, and all of that. And we'll see you again soon. Stay tuned for more events coming up. Follow us on Traefik, please. Take care. Bye, Nicholas. Thanks.
Goodbye. Thanks.